Okay, this is sample problem 6.8. List the values of n, l, and m sub l for each of the orbitals in a 4D subshell. Okay, so let's do quickly, let's do a little review here. We're talking about the hydrogen atom in this section. So we have 1s is at the lowest energy. Above that is the 2s, but when you get to the second shell, you can now have p. So these are two p's. So notice in the first shell, this is shell 1. This is shell 2. In the second shell, there are 4 orbitals, but in the first shell, there's only 1. And then as you increase, I'm going to show them a little more evenly spaced, even though they do converge. 3p, 3p, 3p. Now you have 3D. SPD. And there's 5 of these. So I would recommend you memorize the pattern. 1 for the s, 1 orbital. 3 possible orbitals for the p. And then 5 possible orbitals for the d's. Now when you get up to the 4th level, I'm going to have to draw these even smaller. And squinch them together. Now we're not going to need it for this particular problem, but I want to, oops, sorry, this is a 4. This is the 4th level, 4D. We don't need it here because the question really is just the 4D subshell. 1, 2, 3, 4, 5, 6, 7. These are 4F. So notice the pattern. It's 1 orbital for the S, 3 for the P, 5 for the D, and then 7 for the F. So I'm going to try to show you down here the subshell, SPDF, number of orbitals. One, 3, 5, 7. Okay? And again, we could go through the M sub L. In fact, we'll have to go through the M sub L from this. The reason it's 1, 3, 5, 7 is because of the possible values of M sub L. Okay? So let's list all the values here that are possible for the 4D subshell. So 4D. So we're using this orbital notation here. Orbital diagram notation. The number in the front, that's the value of n. So that tells us right there that we're talking about n equals 4. So that's this shell here. It could be any of these orbitals in the 4th shell. Okay? But this gives us even more information. The D tells us that L equals 2. That's what that's telling us. Okay? So again, reminder, for the L values, it's 0, 1, 2, 3, and that's S, P, D, F. Meaning the value of L determines what the name we're going to use. So if we call it a D, that means L equals 2 from that chart down below. So we know the first 2, right? So that means we're talking about this subshell. So when you see this notation 4D, that's telling you the subshell. So you could have a different subshell. For example, right here, we would call this the 3P subshell. Or we would call this the 1S subshell. So the subshell is defined by the notation here, the number with the letter. Okay? Now, to figure out what M sub L could be, we have to go back to what we covered in the previous section, which is that M sub L goes from minus L all the way up to 0, and then all the way up to plus L. So we already know L is 2, so that means it goes from minus 2 up to plus 2, right? We know it's 2 because of the D, so we know that. So now we say M sub L is minus 2 or minus 1 or 0 or plus 1 or plus 2. It could be any of those 5 values, and here we go. Minus 2, minus 1, 0, plus 1, plus 2, right? So that's why there's 5 orbitals in the 4D subshell, is because those 5 values are limited by what L can be. If L is 2, M sub L can only be one of these 5 values, or it can be one of those 5 values. So you get 5 orbitals there. So our answer would be 4 for N, 2 for L, and 5 different possibilities for M sub L.